Arduino Project number 5, 6, and 7 by Janina May B. Pozo, John Joseph Cepeda, and Dustin Dalisay. Project number 5, Water Level Indicator using LEDs and buzzer. How it works. In this project, we will be building a water level indicator using Arduino and water sensor. The system would indicate the level of the water inside the tank with the help of 3 LED and a buzzer to indicate that the tank is full. Water sensor brick is designed for water detection, which can be widely used in sensing rainfall, water level, and even liquid leakage. Connecting to a water sensor to an Arduino is a great way to detect a leak, spill, blood, rain, etc. It can be used to detect the presence, the level, the volume, and the absence of water. In preparation, here's the materials that we use. First is the Arduino Uno water level sensor, 3 light emitting diode, 1 active buzzer, connecting wires, breadboard, and 3220 resistor. Steps: first, assemble LEDs on breadboard. Second, use LED of 3 different colors: red indicating extremely low level, yellow or blue indicating half water level, and green indicating full water level. Number 3, connect the shorter legs to GND rail on the breadboard. Provide a jumper wire connected to GND from Arduino board, which would be the ground supply. Fourth, connect 220 resistor in series with each LED. Next, project number 6, Flame Fire Detection Sensor. How it works. A flame sensor is used in detecting fire and activate alarm once the fire is being detected. One of the simplest way to detect fire is by using an IR flame sensor. This sensor have an IR photodiode which is sensitive to IR light. Fire alarm systems are very common in commercial buildings and factories. This device usually contains a cluster of sensors that constantly monitor for any flame, gas, or fire in the building and triggers an alarm if it detects any of these. Now, in the event of a fire, the fire will not only produce heat but will also emit IR rays. Yes, every burning flame will emit some level of IR light. This light is not visible to human eyes but our flame sensor can detect it. Preparation. Parts required are Arduino Uno, flame sensor, 1 red LED, buzzer, connecting wires, breadboard, 1 to 220 resistor. Steps: connecting the buzzer, connect the buzzer to digital pin 9 and the other leg to GND. Number 2, connecting LED. Connect the shorter leg of the LED to GND and the longer leg via 220 resistor to digital pin 8. Number 3, connecting flame sensor. Place the sensor on the breadboard wherein the one end of the 330 resistor is placed on the longer leg of the sensor and the other leg is connected using jumper wire to Arduino 5B. Connect the longer leg of the sensor to analog pin 0 and shorter leg is connected to GND. Last project is the number 7, Tilt Movement Detection Sensor using LED and buzzer. How it works. The activity required to detect a tilt motion from the tilt sensor. If the sensor detects a misimbalance from its position, there will be buzzer signifies that the sensor is lifted or imbalanced. The activity must be worked based on the position of the subject matter. This can be used to detect movements and can be used in an earthquake sensor, probably. A tilt sensor switch is an electronic device that detects the orientation of an object, gives its output high or low accordingly. Basically, it has a ball inside it which moves and makes the circuit so tilt sensor can turn on or off. In this project, we are interfacing the sensor with Arduino Uno and we're controlling a LED and buzzer according to the output of the tilt sensor. Whenever we tilt the sensor LED, and the buzzer will be turned on. Preparation. Parts required are Arduino Uno, tilt sensor, 1 red LED, and 1 active buzzer, connecting wires, breadboard, 220 resistor, and 10K resistor. Next is the steps. Number 1. Connecting the buzzer. Connect the buzzer to digital pin 9 and the other leg is to GND. Connecting LED. Connect the shorter leg of the LED to GND and the longer leg via 220 resistor to digital pin 8. Connecting tilt sensor. Place the sensor on the breadboard wherein the one end of the 10K, the 1K resistor is placed on the one leg of the sensor, and the other leg is connecting using jumper wire to Arduino 5B. Connect the one leg of the sensor to analog pin 0 and the other leg is connected to GND.